In this video, I'm going to take a look at hypothesis testing for the parameter of a geometric distribution. Now let's just start by recalling that the geometric distribution can be used to model the number of trials required to achieve the first success. So hypothesis testing for the parameter p of a geometric distribution allows us to answer questions such as whether a dice is biased. And as always, for any hypothesis test, we should start by forming our hypotheses. So we have the null hypothesis to begin with. So this is h0, and we have the parameter p then. So we say that the parameter p is equal to some value m. And this is the value of p that we assume to be true. Okay, so that's the null hypothesis, so that's h0. And we also have the alternative hypothesis h1. And this tells you about the value of p if our assumption is shown to be incorrect. Okay, so that's the basic idea there behind the null hypothesis and the alternative hypothesis. Now, we do need to be slightly careful here when calculating the value of the test statistic. Now, let's say we have a one-tailed hypothesis test that looks something like this here. Okay, so we've got h0 and h1 here. This gives us our hypotheses. Then our test statistic would be calculated here as the probability that our random variable x here is greater than or equal to some value x. Okay. Now, notice here, this is the opposite of what we would normally expect, because h1, we have the parameter p then being strictly less than m. So normally here, for the test statistic, the random variable x would be less than or equal to x because it matches up with h1 here and the inequality used in h1. However, for the geometric distribution, we always have the opposite. So if this is less than, we test for our random variable x being greater than or equal, and if this was greater than, then we'd be testing for the probability of our random variable x here being less than or equal. Okay, so it's always the opposite of what we have in h1. So what we're testing for here is our random variable x being greater than or equal to our observed value. Okay. And the reason for this is because as the value of p increases, the mean of our geometric distribution decreases. So when we set up a hypothesis test to assess whether the parameter p of a geometric distribution has increased, you need to determine whether the test statistic falls in the lower tail of the distribution and vice versa. Okay, so it's an important point there to make. Do be aware of that. So it's always the opposite of what we have here for h1. So if p is less than m, we test for the probability that x is greater than or equal to some value, where this value here is our observed value. Okay, and vice versa. Now you might find it useful to note the following results here before we look at some practice questions. So if x follows a geometric distribution with the parameter p, we can use the following three results here. Now, hopefully you are familiar with all three results here because we have seen these in a little bit more detail when we introduce the geometric distribution. Okay. But other than that, that gives us everything that we need here then for our introduction here then to hypothesis testing for the parameter of a geometric distribution. So let's take a look now at some practice questions. Let's get started then with question 1 here. So for question 1, we have a random variable which has a distribution of x, which follows a geometric distribution with parameter of p. We're then told that a single observation of x equals 3 is obtained, and we want to use this observation to test p equals 0.02 against p being greater than 0.02 using a 10% level of significance. So the first thing that I'm going to do here is just rewrite the hypotheses. So we've got h0 and h1, and I do know that they're already given here clearly in the question, but I do always like to start just by writing them down myself. So we've got h0 here for p being equal to 0.02. So p is equal to 0.02. And then for h1 here, this is for p being greater than 0.02. Okay, like so. Now what I'm going to do next here is assume that h0 is true. So we assume that h0 here is true. Now why do we do this? Well, we have the random variable x here, which follows a geometric distribution with parameter p. So if we assume that h0 is true, then p is equal to 0.02. So x here follows a geometric distribution with parameter of 0.02 then, like so. Now, in terms of the evidence here for the single observation, what are we testing for here? So what we're looking for is the probability that our random variable x here. Now, given that h1 is for p being greater than 0.02, we test for then the probability that our random variable x here is less than or equal to our observed value, which in this case is 3. Okay. Remember, for a geometric distribution, it's the opposite of what you'd expect here with H1. Okay. So in that case then, testing for this probability here using a geometric distribution, what would we get then? Well, this will be 1 minus p to the power of x here, okay, where x is our observed value. So we do 1 minus p, so that's 1 minus 0.02. So 1 minus 0.02. And as we said, this here is to the power then of our observed value of 3. So that's the power of 3. So if we simplify this here and evaluate this, we get 1 minus 0.98 to the power of 3. So if I just quickly do that on my calculator then, let's see what we get here. So 1 minus 0.98 to the power of 3, or 1 minus 0.98 cubed. And if we do this correctly then, what we get here is 0.0, so 0.0588. Okay, so we get 0.0588. Now what we need to do is compare this here to our significance level. So we have a 10% level of significance. So in this case, this value here, the test statistic, is less than the significance level. So 0.0588 is less than the significance level of 10%. Don't forget we have a one-tailed hypothesis test here, so we don't need to half this. So this is less than 0.1. So therefore in that case then, we reject H0 here. So therefore we reject H0. And there we have it. We don't really have any context to the question here. There's nothing that we can actually, conclude with. So we just say reject H0. Okay. In other words, we have sufficient evidence at the 10% significance level. But there we have it. So that gives the solution there to question 1. Let's just take a look then at one more question here. So we have question 2, and for question 2, we're told that whilst playing darts, Ben requires, on average, 4 throws to hit the bullseye. After changing to a new set of darts, Ben hits the bullseye on his 10th throw. So this question asks us to test at the 5% significance level whether the probability of Ben hitting the bullseye is now less than 1/4. Now, given that we're hypothesis testing here, a good place to start is to define the hypotheses. Okay, so we've got H0 and H1. So H0 here and H1. Now clearly we're testing for the parameter P of a geometric distribution. So P for H0 and for H1 here. So for H0 then we're testing whether P is equal to this value here of 1/4. So P is equal to 1/4. And then clearly for H1 here, we're testing for P being less than 1/4. Okay, like so. Now what I'm going to do next here is assume that H0 is true. So I assume H0 is true. Okay. Now why do we do this here? Well, let's choose a random variable to model this situation then. So I choose x here as my random variable. Then x will follow a geometric distribution with a parameter of p. However, if we assume that H0 is true, then P is equal to 1/4. So we obtain this distribution here, like so. Now for the test statistic then, we're looking for the probability then that our random variable x here. Now given that H1 for P here is less than 1/4, this will be greater than or equal to the observed value of 10. Okay. Remember, for a geometric distribution, it's always the opposite of what we have for H1. Okay. So to find this probability here, this would simply be just going to be 1 minus P, so 1 minus 1/4, to the power then of this value here, minus 1. So that's to the power of 10 minus 1, like so. Now from here then, all we need to do is simply use our calculator here to evaluate this probability. So this would simply be 3/4 to the power of 9. Like I said here, just use your calculator to evaluate this probability. And if you do this correctly then, what you should find here is you get 0.0751. Okay. Now what we're going to do here is take this value, the test statistic, and compare this to our significance level. Now 0.0751 is greater than our significance level here of 5%, so that's 0.05. So therefore in that case then, what we're going to do here is accept H0. So we accept H0 here. Now given that we do have context to the original question here, what we need to do is give a conclusion in context. So in that case then, I'm going to say here that there is no reason to conclude that the probability of Ben hitting the bullseye is now less than 1/4. Okay, so no reason to conclude that the probability of Ben hitting the bullseye let's write this down in full. So the probability of Ben hitting the bullseye is now less than 1/4. Okay, something along those lines that summarizes in context what we found here for the conclusion of this hypothesis test. Okay, but there we have it. So that gives the solution there to the very last question, question 2. And that brings us to the end of this video on hypothesis testing for the parameter of a geometric distribution.